In this video, we'll start doing integration of trigonometric functions, which is exercise 7.3 from your NCERT textbook. We'll look everything from scratch. We'll look at all the trigonometric results that we'll use, including half angle formulae, defactorization formulae, also trigonometric identities. So even if you don't know for now any of the formulas, don't worry. This video got you covered. Let's see what we are doing in this video. Before we start with exercise 7.3 from your textbook, it's important that we do a quick recap of all the trigonometric results that we'll use while integrating the trigonometric functions. Let's start with trigonometric identities. Now we know there are three trigonometric identities. Let's write it down quick. The identity 1 is sine square theta plus cos square theta is 1. That's the first trigonometric identity. The next trigonometric identity is 1 plus tan square theta is equal to sec square theta. And the third trigonometric identity is 1 plus cot square theta is equal to cosec square theta. All right, so that's the trigonometric identities. Now let's look at very important, very critical for integration, which are half angle formulas. Almost every integration problem of trigonometry will use half angle formulas or defactorization formulas in some way. So it's very important to remember these. Let's look at sine 2 theta. Now half angle formulas are basically the formulas that will divide your angle into half. So the formula for sine 2 theta is 2 sine theta into cos theta. The formula for sine 2 theta is 2 sine theta into cos theta. Note that the angle here becomes half, so that 2 theta becomes theta. You can also extend this idea. If it was 4 theta here, this would have become 2 theta on the right hand side. Okay, so this is a general formula. Whatever the angle here, it will become half on the right hand side. Okay, that's one formula for sine 2 theta. There is another formula for sine 2 theta. It is 2 tan theta divided by 1 plus tan square theta. Again, also the angle here is again half. If it is on the LHS 2 theta, on the right hand side, it will become theta. Okay, all right. Before going to cos, let's just quickly write tan because it's so similar to this sine 2 theta. In sine 2 theta, there is positive in the denominator, but in tan 2 theta, it's just negative here. So the tan 2 theta half angle is 2 tan theta divided by 1 minus tan square theta. Okay, remember that in sine, it's positive here. In tan 2 theta, this is a negative here. Again, the angle is half. If it is 2 theta here, the angle becomes theta here. Okay. Now for cos 2 theta, there are four formulas that we have for half angle. The formula number 1 is cos square theta minus sine square theta. In all the formulas, the angle is half. If it is 2 theta here, it becomes theta on the right hand side. That's the first formula, cos square theta minus sine square theta. The second formula is 2 cos square theta minus 1. The third formula is 1 minus 2 sine square theta. And the last formula, which is the fourth formula for cos 2 theta, is 1 minus tan square theta divided by 1 plus tan square theta. Okay, so cos 2 theta has four half angle formulas. In all the formulas, the angle is half. Okay, whatever the angle on left hand side, if you notice, the angle is half. Here, if it's cos 2 theta, it becomes cos theta. If it was 4 theta, the angle here would have been 2 theta. So whatever the angle is, it will become half in all these formulas, which is why they are called half angle formulas. All right, now let's look at some special formulae of trigonometry that we use very frequently in integration. Those are the formulas of sine square theta, cos square theta, sine cube theta, and cos cube theta. Now, the reason I call these formulas special are because, for example, let's take sine theta. We know the integration of sine theta is minus cos theta, but we don't directly know the integration of sine square theta. There is no chain rule as such in integration. So in order to integrate sine square theta or cos square theta or sine cube theta or cos cube theta, you have to convert those power 2 into power 1. Okay, so basically these special formulae are the formulas that will convert power 2 or power 3 into power 1. Okay, let's see how to write those formulas. So if it's sine square theta, the formula is 1 minus cos 2 theta divided by 2. So that's the formula for sine square theta. You convert that power 2 here into power 1 on right hand side. Okay, for cos square theta, it's just plus. So it's 1 plus cos 2 theta divided by 2. Again, you convert that power 2 on the left hand side into power 1 on right hand side. Okay. Also note that the angle is half. That theta becomes on the right hand side 2 times. Again, that theta on the left hand side, on the right hand side, that becomes 2 times. Okay. So you have to double the angle on the right hand side. Let's take one example. Let's say if it was sine square 10 theta. If it was sine square theta, the formula is 1 minus cos 2 theta divided by 2. If it was sine square 10 theta, the formula is 1 minus cos. If it's 10 theta, you write 20 theta divided by 2. You just double that angle, and that power 2 gets converted to power 1, which then becomes easy to integrate. Okay. For sine cube theta and cos cube theta, in order to convert that to power 1, we use the formula for sine 3 theta and cos 3 theta. Sine 3 theta and cos 3 theta. So sine 3 theta, the formula is 3 sine theta minus 4 sine cube theta. So I like to remember this formula is 343. 343. Okay. And for cos, I like to remember the formula as 43 3. So the formula is 4 cos cube theta, 43, 4 cos cube theta minus 3 cos theta. So I can find the values of sine cube theta and cos cube theta from these equations. So from here, if I want to find sine cube theta, the equation will turn out to be, you can bring this expression on the left hand side and sine 3 theta on the right hand side. So my sine cube theta will become 3 sine theta, 3 sine theta minus sine 3 theta divided by the 3 sine theta minus sine 3 theta divided by this 4. And similarly, cos cube theta will become, take this 3 cos theta on the other side. So you get cos 3 theta plus 3 cos theta divided by that 4. So these are the formulas. Also remember here that this theta over here, it becomes 3 times, and this theta over here becomes 3 times. Okay. Now, the last set of formulas that we want to see are defactorization formulas. Now, defactorization formulas are the formulas where you convert product into either addition or subtraction. So here there is a product, everywhere there is a product. I convert those products into either addition or subtraction. Now, why would I do that? Now, you know that in integration, it is difficult relatively to integrate a product rather than to integrate addition or subtraction. So whenever you have multiplication or product of two trigonometric terms like sine, cos, you convert that product into addition or subtraction using defactorization formulas. So defactorization in general is a process to convert product into either addition or subtraction. Okay, now let's see how those formulas turn out to be. Whenever you have sine, cos, so all the formulas, let's remember it like this. All the formulas start with half. Every formula will start with 1 by 2. Just the last one, which is sine and sine, it has minus 1 by 2. Okay, so remember, when there is sine and sine, it is minus 1 by 2. And all the formulas involves two terms. So I put a bracket. It's either addition of two terms or subtraction of two terms for all the formulas. When there is sine and cos, the formula is sine plus sine. Whenever there is sine cos, the formula is sine plus sine. Whenever there is cos and sine, the formula is sine minus sine. And whenever there is cos, the formula is cos plus cos. And whenever there is sine, the formula is cos minus cos. Okay. Now the only thing left is angle. So angle is always a plus b and a minus b. So it's addition of two angles and then subtraction of two angles. So a plus b and a minus b. Even here a plus b and a minus b. A plus b and a minus b. There is one not so strict rule. Remember that for all those, a greater than b is preferred. Okay. So if it's a greater than b, it will become a little bit simple for you. It's not a strict rule. Okay. Not a strict rule. Not a strict rule. We'll see it with an example on how, what do I mean by this. But remember, try to keep a greater than b. So put the greater angle first and then put the smaller angle. Okay. That will make your simplification little bit easier. And it will not make a whole lot of difference, but just a little bit easier. Okay. So it's not a strict rule anyway. All right, now let's start solving exercise 7.3 from your NCERT textbook. In this video, we'll solve question number 1 to 5. Okay, let's start with the first one. So the question number 1 says sine square integrate sine square 2x plus 5. Now the moment I see sine to the power 2, I know that I want to convert that power 2 into power 1 using the formula that we discussed. Now we know that sine square theta, the formula is, for sine square theta, the formula is 1 minus cos 2 theta divided by 2. So that angle becomes double on this side. Okay. So this will become integration of 1 minus cos. You just double that angle. Okay. So you just double that. So that 2x will become 4x plus that 5 will become 10 and divide by 2 and dx. Very simple. We just use that formula to convert sine square from power 2 and to power 1. Okay, now take that half out, which is the constant of the constant in the integration, take it out. So you get integration of 1 minus cos 4x plus 10 dx. Okay, now give the integration to both of these terms. So you get half bracket integration of 1 dx, give that integration to 1 minus integration of cos 4x plus 10 dx and bracket closed. Now let's integrate that. Half, we know integration of 1 is x minus, we know integration of cos x dx is sin x, but this is not cos x. This is a linear term in cos x. We have also studied that if it is instead of x, if there is ax plus b dx, if instead of x there is ax plus b that you want to integrate, the same formula can still be applied. Cos ax plus b, the integral is sine ax plus b. You just have to divide by coefficient of x. So coefficient of x, which is a. Okay. So here the formula will become, or the integral here will become, so the integral of cos is sine 4x plus 10. You just have to divide by coefficient of x, which is 4 bracket closed, plus add a constant of integration c. Now just to simplify this a little bit further, just multiply this half inside. So you get half times x, which is x by 2, minus half times this 4. So 2 times that 4 is 1 over 8 sine 4x plus 10 plus c. That's the result of our integral. I hope that makes sense. Let's look at question number 2, which is integration of sine 3x into cos 4x dx. The moment I see the product or multiplication of sine and cos, or cos and sine, or some combination of sine and cos, I understand that I have to convert that product into either addition or subtraction using defactorization formulas that we just studied. Okay. So we also studied that it is preferred that so this is 3x and this is 4x. It is preferred that you put the greater angle first. So let's just write this as integral of cos 4x into sine 3x dx. it's just preferred to write it like this to make your calculation little bit easier. Okay, so always have greater angle first and then write smaller angle. Now this is cos and sine. We know the formula was for cos and sine. If you have cos A and sine B, the formula was half. Every formula starts with half. Half, the formula was sine minus sine. The formula was sine minus sine. In the first, you add the angle. In the first sign, you add the angle. In the second, you subtract the angle. So that was the formula. So if you apply that formula here, so you get integral of cos 4x sine 3x. The formula starts with half. It's sine minus sine. So you write sine minus sine, close the bracket, and dx. In the first sign, add the two angles. So 4x plus 3x, which is 7x. In the second sign, subtract the two angles, a minus b. So 4x minus 3x, which is 1x. Very simple. Now in the next step, you take that half, which is constant of the integration, out. Okay, you take that half out, and you are left with integration of sine 7x minus sine x dx. Okay, I think so far it makes sense. Now just split the integration in two terms. So you get half, put a bracket, integration of sine 7x dx minus integration of sine x dx. Okay, now it's very simple, just the integration of sine, which is minus cos. So you write half integration of sine 7x, which is minus cos 7x. But remember that you have to divide by that coefficient of x, which is 7, minus. Again, integration of sine x is minus cos x. Close the bracket, add the constant of integration c. That negative and negative will become positive. So you will get half minus cos 7x divided by 7 plus cos x plus the constant of integration c. And that's your final result of integration. I hope that makes sense. All right. Now the question number 3 says integral of cos 2x, cos 4x, cos 6x dx. Okay. Now I like to keep it in descending order. So the greater angle first, then the smaller, and then the smallest. That just makes my calculation little bit easier. So you get integral of, right, cos 6x times cos 4x times cos 2x dx. Okay, then since it's the product of cos, you have to convert that product into either addition or subtraction using defactorization formulas. Now we know the formula says if it is cos and cos, if it is cos A and cos B, if it is cos A and cos B, the formula starts with half, and the formula says it is cos plus cos. Okay, and the angle is A plus B and A minus B always. Okay, that's the formula. So now let's apply that formula here. Let's take two terms at a time. Okay, it doesn't matter which two terms you take. Let's take the last two terms here. So you get integration of cos 6x times. Okay, so the formula says it starts with half. So formula starts with half, and it is cos plus cos. In first, you add the two angles. So 4x plus 2x, 6x. In the second part, you subtract the two angles. 4x minus 2x, it is 2x. Okay, close the bracket and write dx. Okay, I hope it makes sense so far. Take that half, which is constant of integration. Sorry, it's the constant in the integration. Take it out. So you get half integral of cos 6x times cos 6x times, sorry, plus cos 2x. Okay, and with respect to x. Okay, basically take this half out, which is the constant, and you get cos 6x times cos 6x plus cos 2x. Now multiply cos 6x inside the bracket. So you are left with half integral of, let's put a bracket, and we get cos square 6x plus cos 6x into cos 2x dx. Okay. Now the first term is cos square 6x. We know that cos square theta, we can convert that into power 1 by the formula 1 plus cos 2 theta divided by 2, that formula that we just discussed. So we get half integral, open the bracket, cos square 6x can be written as 1 plus cos, you double the angle. Whatever the angle is here, you just double it. So 1 plus cos 12x divided by 2 plus, now this cos 6x and cos 2x, we can apply this formula here. Okay, this defactorization formula again. So we get half. So this cos 6x times cos 2x can be written as half cos plus cos. So you get cos plus cos. Let's close the bracket. And in the first part, you add the two angles. 6x plus 2x, you get 8x. 6x minus 2x, so you get 4x. Okay, now let's erase that formula to make some space here. Okay, and that is with respect to x. And let's close that bracket here. Okay, I hope that makes sense so far. Okay, now we can simplify this further by there is half in this first term, and then there is half in this first term. So that half and this half can be taken out, and this half will become 1 by 4. Okay, then you get integration of bracket 1 plus cos 12x plus cos 8x plus cos 4x dx. I hope that makes sense so far. You just take that half which is in the first term and half it is in the second term. Just take that half out so that this will become 1 by 4. And you are left with 1 plus cos 12x plus cos 8x plus cos 4x. Now split the integration in all the terms. And we are almost there at that point. 1 by 4 integral of 1 dx plus integral of cos 12x dx plus integral of cos 8x dx plus integral of cos 4x dx. And let's close that bracket. Okay, that's what I have so far. It's very easy now just to integrate. 1 by 4 integral of 1 dx is x plus integral of cos 12x dx. The integral of cos is sine. So you get sine 12x. You divide by the coefficient of x, which is 12, plus, again, integral of cos 8x is sine 8x. Divide by the coefficient of x, 8, plus integral of cos 4x is sine 4x. Divide by 4, plus add a constant of integration c, and that's your final result. All right, now let's look at question number 4. Sine cube 2x plus 1. We know the formula. We need to convert this power 3 into power 1. We know the formula for sine cube theta. We know the formula for, it starts with sine 3 theta. We know the formula of sine 3 theta is 343. So which is 3 sine theta minus 4 sine cube theta. I just try to like to remember this as 343. Okay, so therefore from this equation we can calculate sine cube theta as take that 4 sine cube theta on left hand side and take this sine 3 theta on right hand side. So you get 3 sine theta minus sine 3 theta and divide by this 4. Okay. Now apply this formula over here. So you get integration of 3 sine theta. So 3 sine 2x plus 1 minus sine 3 theta. So triple that angle. Sorry. So triple that angle. So 3 times 2x is 6x plus 1 times 3 is 3 because it's 3 theta. So you double that angle over here and then you divide by 4 dx. Okay, I hope that makes sense. Take that 4 out of integration because it's a constant. So you get 1 over 4 integration of 3 sine 2x plus 1 minus sine 6x plus 3, close the bracket, and dx. Now it's very easy, just give the integral to both the terms. So you get 1 over 4 integral of 3 sine 2x plus 1 dx minus integral, just give the integral to the second term now, sine 6x plus 3 dx, close the bracket. Okay, now let's integrate those. It's very simple now at this point to integrate. So take this 3 out of that integration here. Then you get the integral of sine is cos. So you get minus cos 2x plus 1, and the coefficient of x here is 2. So always remember to divide by that coefficient of x, which is 2, minus, again, integral of sine is minus cos 6x plus 3. Again, coefficient of x here is 6. So divide by 6, close the bracket, add the constant of integration c. Now that negative negative will become positive. So you are left with 1 over 4. Then this is 3 by 2 minus 3 by 2 cos 2x plus 1 plus 1 by 6 cos 6x plus 3 and plus the constant of integration c. That is your final result. If you want, you can multiply this 1 by 4 inside. But yeah, that's really it. All right, let's look at question number 5, which is sine cube x and cos cube x dx. Now you can really apply, there are two ways to integrate this. Either you can apply the formula for sine cube x and cos cube x together and multiply them together, and then you'll have to apply defactorization. But the more simpler way here is, because we know the formula is for sine 2x, we know it is 2 sine x cos x. For sine 2x, we know it is 2 sine x cos x. Therefore, we know here from here sine x cos x is equal to sine 2x divided by 2. Sine 2x divided by 2. So here this sine cube x and cos cube x can be converted as sine x into cos x the whole cube. Sine x into cos x the whole cube. Right? Now in here, we know the sine x cos x. The formula is sine 2x divided by 2. So we get sine 2x divided by 2 the whole cube dx. I hope that makes sense so far. I have just applied this formula here. Okay. Then just apply cube in the numerator and in the denominator. So you get sine cube 2x divided by 8 dx. Take that 8 out of the integration. So you get 1 over 8 integration of sine cube 2x dx. Now it is again power 3. I need to convert that power 3 into power 1 using the formula of sine. I know sine 3 theta is 3 sine theta minus 4 sine cube theta. Therefore, my sine cube theta is this sine cube theta from here. Take it on the left side, take sine 3 theta on the right side. So I get 3 sine theta minus sine 3 theta divide by that 4. Okay, so basically I get 1 over 8, apply that formula, integration of 3 sine theta. So 3 sine 2x minus sine here 3 theta. So 2x times 3. So it is 6x divide by 4 with respect to x. After this, take this 4 out. So 8 times 4 is 32. So you get 1 over 32 integral of 3 sine 2x minus sine 6x dx. Okay. Now you can just split the integration in both the terms. So you get 1 over 32, put a bracket, integration of 3 sine 2x dx minus integral of sine 6x dx, close the bracket, with respect to x. Okay. Now it's very simple, integration of sine x now. So 1 over 32, put a bracket. Take this 3 out of integration. Integral of sine 2x is minus cos 2x divided by the coefficient of x, which is 2, minus, again, integration of sine 6x is minus cos 6x divided by coefficient of x, which is 6, right? Put a bracket, close the box bracket, and we already integrated. So add the constant of integration c. Now it's just a matter of little bit simplification. This negative negative will become positive. Okay. So this 32 can be multiplied inside really. So you get 3 over 32 times 2, which is 64, and minus cos 2x plus cos 6x divided by 32 times 6, which is 192, plus the constant of integration c, and that is your final result. I hope that makes sense.